So if I have the equation 3x plus 2y equals a negative 2, and I have the equation negative 4x plus 5y equals a negative 28, I need to go through and graph each of those on the same coordinate axis. Okay. Does that make sense?
Mm-hmm.
In other words, you have to use some graph paper. And you can't do this on a sheet of paper and draw your own axis because of the simple fact you aren't precise enough in your units. And you will also find that even using graph paper is not always the most convenient. But the first thing that we have to do if we have these equations is take the first equation and put it into slope-intercept form. So in order to put the first equation into slope-intercept form, what do I need to do?
Remove the 2y. Or yes, subtract 3x.
Okay, so I need to take 3x plus 2y equals a negative 2, and I need to subtract 3x from both sides. So right now I would have 2y equals negative 3x minus 2. Have I put it into slope-intercept form?
No.
What does slope-intercept form look like?
You have to divide by 2, so just go y.
Okay, so I divide everything by 2. So I'd have y equals a negative 3 halves x minus 1. Okay? From that, what do I know to graph?
Start at the negative 1.
Okay? Yes, I will start at the negative 1. I also know the slope. So the b, or the y-intercept, is a negative 1. So I need to draw me a nice simple little graph. This is my x-axis, this is my y-axis, and from what you said right here is I need to start at a negative 1, which is right here, and my slope's at a negative 3 halves, right? So what does that mean that I need to do with the slope from that point?
You go down 3 over 2. Down 3 to the right 2, or up 3 to the left 2.
So I go down 3,
To the right.
to the right 2, or I could have gone up 3 and to the left 2, and I have to draw that line. Okay? So far so good? Doesn't give me a solution yet because I haven't worked with the other equation, right? Okay? So this happens to be the 3x plus 2y equals a negative 2. The one in the green. So far so good? Now we have to work with the other equation. So in the other equation I have a negative 4x plus 5y equals a negative 28. I need to put that in the y equals mx plus b format. So if I'm going to do that, what do I need to do?
Add 4x to both sides.
Okay? So I need to add 4x add 4x. So I'll do this one a little differently. So I need 5y equals positive 4x minus 28. Right? Now what?
Divide by 5.
Okay? Well, that's going to be nice, isn't it?
No.
Negative 28/5. I still need to find it on the graph. What's negative 28/5 equal to as a mixed number?
Like 7, no. 6 something? No. 4. No,
No,
8.
5.
5 and 3/5. 5 and 3/5.
Yeah.
I would say a negative 5 3/5, right? 5 goes into 28 5 times, leaves me with 3. So on my graph, I know that the slope is 4/5. I know that the y-intercept is a negative 5 3/5. So a negative 5 3/5 is going to put me at 1, 2, 3, 4, 5. 3/5 will put me about right there. Can you see that? Can you see the dot? Can you see the big finger? So what do I do with the slope then that was 4/5?
Go up 4 to the left. To the right. To the right half.
Okay, so I go up 4, so that put me 1, 2, 3, 4. Right?
Yeah, I'm going to the right half.
1, 2, 3, 4, 5. All right there? If I need another point, go up 4. 1, 2, 3, 4. To the left or to the right. 1, 2, 3, 4, 5. Looks like stair steps. Very carefully draw the line. How do I find the solution? What did I tell you earlier?
It's the point where they cross.
Point where they cross, correct? Okay? So on this one, if I was looking for the point where they cross, this one happens to be nice enough that whenever you draw it, it crosses right there. Okay? If it crosses there, what is that point as an ordered pair?
2, negative 4.
2, negative 4. You have just solved two equations with two unknowns by graphing. If you have a graph that crosses just like this one does, and they'll only cross in one place, they won't cross in a dozen different places. If they cross each other once, they are called consistent and independent. If they cross each other, they are called consistent and independent. And this would be the solution. Okay? Pretty simple. What happens if I have a graph that for some reason, when I graph it, it has two parallel lines that never meet. Will I have a solution?
No.
If they never meet, there's never going to be a solution, right? Never, ever, ever going to be a solution. Ever. Ever, ever. These are called inconsistent. If they never meet, they are going to be called inconsistent, which means no solution, they are parallel. Which means if you put them into the y equals mx plus b format, what will happen with the slopes?
They'll be the same.
They will be exactly the same, but have two different y-intercepts in order to be parallel, right? Just like this one. It has a y-intercept here and here. The slopes are the same, but don't they have two different y-intercepts? Therefore, they're going to be parallel, which means that they are going to be inconsistent. Okay? But another thing happens, though, if they have the same slope and the same y-intercept. If they have the same slope and the same y-intercept, doesn't it mean that I'd have a line like this? And the second one would actually be right on top of it? If they have the same slope and the same y-intercept? They would be the same exact line, wouldn't they? Okay? We have a special name for those. They are called consistent and dependent. How many solutions do you have if you have exactly one line on top of the other one? How many solutions?
Infinite.
You have infinite solutions. Okay? So that means that they are actually almost parallel, meaning they have the same slope, same y-intercept. Make sense? Okay?